We are starting in a minute. I will actually wait a couple of minutes, given we are not that many in the group in the channel at the moment. So take it easy, get a coffee, get something to drink, and we'll start in a few minutes. So it's 3 minutes past 8. I see we do have some people in the room, but I would wait another couple of minutes, see if someone else might join. So we'll start in 2 minutes. Okay, it's 5 minutes past 8. I see we are slowly growing in numbers. So good morning, everyone. I'm Max. My name is actually a bit longer, Massimiliano. Together with me, there is Adrian today from ISOC, and then you see another account called ISOC Live. That's the one that does the live streaming connected to this event. I would ask Adrian if it's possible for him to start the recording. Can you do that?
Yes, let me do that.
Recording in progress.
Perfect, thanks. So, good morning, everyone. I'm Max, and today I will be doing this second round of the RPKI tutorial. The first one was on Monday. Today is Wednesday, today's the 6th of July. Yes, I need to get my numbers straight. Differently from the session on Monday, we are not going to have the presentation about IRR Explorer, but well, I can still show you how what we're going to do with ROAS in the LIR portal will affect what we see in IRR Explorer. The tutorial is going to be almost, well, I wouldn't say 2 hours long, should be a bit shorter than that. And here is the, the agenda. So we have a very tiny introduction. Then I will give you an overview of what RPKI means. So the different parts RPKI is composed of. And then we'll go into more details. We'll look at ROAS, what they are, how you create them, what data they carry around. I'll show you a demo where I will create some ROAS. We can delete, create. I can show you everything because I have access to the RIPE-NCC LIR portal as a member. And I have some networks I can use for fun. So we can have lots of fun creating ROAS. And then we'll look at the other side of RPKI. We will deploy. We will see how you run a validator. The installation is really simple, so we will not go into that, but the how you start them. And then the real core of RPKI, we will look at the validation, how this happens, how it works. And then there are 2 demos in one, basically. We will set up origin validation, and while we set that up, the effect will be that we discard BGP invalids. I hope you'll have fun in the next couple of hours. Important thing is, if you have any questions, if you didn't understand something, feel free to raise your hand or just write the question in the chat. If you raise your hand, you can open your microphone. I can stop. We work on the question. I'll see if I can answer it, and then we go ahead. But I would really love for you to ask as many questions as you can, because I really enjoy it when you do. So before we go into RPKI, we have to look at what the problem is on the internet. We have 2 networks in this example, and the 2 networks normally on the internet, they speak BGP. BGP is the fundamental protocol that keeps the internet together. It's a very simple protocol. And its goal is to basically create what are called announcements or BGP updates. In an update, you tell other networks what your prefixes are. So you say, I have these network, in this case, it's 213.xxx, and the other networks receive this announcement and install that in the routing table. They can do some checks, but the fundamental concept behind BGP is that I tell you, I don't know what's happening with my voice this morning, but sorry, 1 second. I tell you So in a BGP announcement, I tell you, this is my network. You can do your checks. You can verify that that's the best path to reach it, but then you install it in your routing table. The same happens the other way around. If I am network B, I receive the announcement from network A that says my prefix is 193.xxx, and I can install it in my routing table. Now, how I do this is really simple. I just add something to my table. But before I can do that, I would have to figure out if this announcement is really legitimate. I would have to figure out if network A is supposed to be telling me that 193.xxx is their network, is their prefix. How do I do this? Intrinsically in the BGP protocol, there is no facility that can help us doing that. So when we ask ourselves a question, can I trust B from network A? Well, I have to figure it out from different sources. The same goes for network B, and I ask myself, is A correct in what they're announcing to me and what I see here? So for years, we've had a way to verify this. In this case, it's the RIPE database, but it's the Internet Routing Registry as a whole in a system. The RIPE database is one of the instances. There is the Afrinic database, there is APNIC, there is ARIN, LACNIC, and there are also, this is an important thing to understand, there are also third-party databases, AltDB, RADB, or databases operated by networks. So entity operator runs their own IRR, level 3 runs their own IRR as well, to help their customers create entries in the routing registry. So using the RIPE database, I can query the RIPE database. The RIPE database has information in the forms of objects that can tell me, is network B supposed to be announcing 213, blah, blah, blah. And then with that information, I can assume that what I see in BGP is correct. So, but with the help of an external database, I can do that. But there is a problem with these external databases. Some of this IRR data cannot really fully be trusted. Some of it lacks accuracy, some of it is incomplete, and there is lack of maintenance. If you followed yesterday's presentation about tools, I presented 2 tools, and I told you that some of the libraries in there are shared by the tools. One of them is to check the validity of root objects. And when I was developing that software, when I was writing it, I was discussing with another colleague, with Amrish, who was on the call yesterday as well. And he told me, and I was asking him, okay, can we come up with a small country where I can check if the data I see in the IRR from the whole country is okay? And then I spent 2 days debugging my tool, which I thought wasn't working. We focused on Mauritius, and we figured out that at the end of those 2 days, where I thought my tool was not working, I discovered, well, it's not my tool that's not working. It's actually the networks in Mauritius who have not really done their jobs. And what is this about? The lack of maintenance means that these objects were left in a database where they shouldn't be. You know, parts of Africa were covered not by Afrinic, but by the RIPE NCC before Afrinic was created in 2006. And so objects before the creation of Afrinic for networks in some parts of Africa, they needed to be created in the RIPE database. Or even after that, they could be created in the RIPE database with a sort of a trick. So you had a special maintainer, you could create those objects anyways. But at one point, a few years ago, the RIPE community decided to take those objects and put them, change the source. So put them in a sort of a slightly different database that tells us this is still the RIPE database, but this is non-authoritative for these objects because we cannot verify, since they're not part of the RIPE region or RIPE NCC delegations or assignments and allocations, we can't verify exactly that the entity who created these objects and is claiming to be the holder of these objects, of these networks, we cannot verify their statements. So I didn't consider checking into the RIPE non-authoritative database when I wrote my tool, but apparently all these objects are still there. They should be deleted from there by the holders and then recreated in the Afrinic IRR. This is something we're going to try to do something about in the future, but for now, that's the situation. And this shows the whole lack of maintenance. This is one tiny example. And then third-party databases are widely used. So I mentioned RADB, I mentioned AltDB. Differently from the Internet Routing Registry from a regional registry like RIPE NCC or Afrinic, a third-party database cannot fully verify that the person creating the data in their database is the rightful holder of a resource. So there are weak authentication mechanisms, but they can't give us the trust that we need when we are looking into authorizing BGP announcements. So from 2008, some people decided, let's put a fix to this. And so at the ITF, people started discussing about adding more trust, adding a way to verify in a better way the data we find in the IRR. So they decided to create RPKI, adding, here we say crypto security, but it's basically adding the capacity of verifying that the data is supposed to be there, that the data is truthful. We added that to IP addresses and ASNs. And the result is that in RPKI, we have data that we can trust way more than we can do with simple route objects in Internet Routing Registries. So how does this work? The regional registries all have a root certificate, and the root certificate covers 0/0, the whole of the address space. It wasn't like this from the very beginning. At the beginning, the regional registries only had certificates covering the address space that they were allocated by IANA, which is the organization that's above the regional registries. But then given there's the chance to transfer addresses from one region to the other, you can do it from APNIC to RIPE, from RIPE to AREN, APNIC to AREN. I haven't kept track if that's already possible in LACNIC, but I know it is not possible yet in Afrinic, or correct me if I'm wrong. So the regional registries all have a certificate that covers the whole of the address space, 0/0, and then every member, in this case, the members at RIPE NCC are called LIRs, local internet registries. They have their own certificate authority. They have their own certificates and objects under them. We'll see what the objects are in a moment. And the two are connected together. So there is a signature from the root that enables us to say this certificate, this CA, or this certificate authority from, this certificate from the member is truthful, is okay, we can still trust it. So we start here with building our chain of trust. That's the fundamental part of RPKI. And then what do we do with RPKI, with resource public key infrastructure? We tie IP addresses to ASNs and then ultimately with public keys. But then very, very important, differently from how the IRR was established. From the very beginning, RPKI follows the hierarchy of the registries. And inside this hierarchy, we get a file, we get a piece of information that tells us this ASN is authorized to announce this prefix. And then there's a signature, there's a digital signature that comes from the holder of the prefix. So you can imagine that with this, we can get ultimate trust, as I mentioned already, in the whole system. So now let's go into more details. What is this information that we're talking about? We have two elements in RPKI. One where we provide this information to some people, we have the signature, and where we create ROAs. So we create information, we create statements, as I mentioned a moment ago, statements that say, this is my prefix, and if you see this prefix on the internet, it should be announced by this autonomous system number. If you see anything different from what I'm saying here, don't trust it. So that's one part. I provide information to others and then totally separate. These are two totally separate parts. I have the validation. So it's very important to understand that I could be signing my data, I could be creating my ROAs without running any validation, and vice versa. I could run validation without having signed any ROAs. So the two parts are totally separate, totally independent. You as a network operator can implement them in separate moments. You can even totally avoid implementing one of them. You can totally avoid creating your ROAs. I would discourage you from doing that, but you can do that. So for now, we are focusing on the left side, on the signature, and we're talking about ROAs. So a ROA is a statement, is a file that contains a prefix, an origin, and then there is an additional piece of information. Wait a moment. So this ROA for now is telling us this AS number is authorized to announce this prefix. And LIRs members can create ROAs as they like for their resources. They can overlap. There can be multiple ROAs for the same prefix, different origin. They can have different max length. We'll see what max length is in a moment. You can make overlapping ROAs. You have total freedom on how you can create them. But what is in a ROA? We've said there's a prefix, the network, there's an origin ASN, but getting into more details, we have an additional point. There's the max length. So the maximum prefix length that ROA is authorized to advertise. So you have the prefix has a prefix length, and then you have another additional parameter that is the max length. And there's the origin ASN. How does max length work? Imagine this is a network /22 and a ROA with a /22, and we have max length says /24. This means that an announcement for a /22, perfectly fine. For /23s, perfectly fine, because we say up to 24. 24s are fine, but 25s are not fine. Forget for a moment the fact that the /25 will be filtered by network operators, will be filtered by other actors on the internet. Forget about that for a moment. In this case, /25s will be filtered in any case because they represent a network that is covered by the ROA. So they fit in the /22 that the ROA says. They don't fit in the max length up to the /24 that we have. So in this case, these announcements would not be accepted. I wonder if this is good so far. If you have any questions, and as I mentioned, let me know in the chat. I'll give you a moment. I haven't seen any chats. I see a thumbs up. Okay, perfect. So I'll go ahead, but don't forget, there's the chat. You can raise your hand. I'm happy to answer any questions. Another example, we have the /21 ROA for AS2121. Max length is 21. So we're very strict with this one. And we have this announcement that is covered. That's perfect. But let me ask you, what about the /22? Any /22? Can you write it in the chat? Would you be accepting those? Okay, I see a no from Paul Ennis. I see a no in the chat from Fariba. I see a no. Very well. Anything that's more specific doesn't work. If I want to announce something more specific, I have the chance to create a more specific ROA. So in this case, a ROA for a /23, max length 24. So in this case, I would be applying a different rule for that specific part of the address space, and I would see that the /23 and the two /24s would be fine. Same thing, I can do it there. And can you tell me which one of the three announcements below that would be allowed to pass in this case? Can you write that in the chat? Okay, I see Fariba saying just the /23. Do we agree? Do we agree with her? Yes. Paul, yes. Godfrey, yes. Well done. Yes, that's what we get. So I see you've fully understood this, but then we also have tricks that can be obtained with the use of max length. Imagine this example. We have a /22, max length 24. In this case, we are announcing out of it just the /23, just one of the /23s below the /22. But imagine we have an actor that's trying to act maliciously. What can they do when the max length is set up this way with a /24 in this case? The attacker could set up imagine the attacker runs a data center or a small ISP. They could set up a router announcing the /24 with origin, your AS number, the origin AS that's in the ROA, behind their own ASN, allowing with filters the announcement to pass by. They can do it also they can also add your ASN to their AS set so that their upstreams will open their filters to allow these announcements to pass by. And what is the trick here? The trick is that by setting up this router, it can be a very simple software router. You can do it in 20 minutes with the origin ASN as same as in the ROA. The prefix length and max length are allowing this to pass. So this would be perfectly valid. So RPKI would not be able to identify that this is coming from an illegitimate source. So here, the suggestion is to create ROAs for BGP announcements only. Cover what you are announcing. In this case, we changed it so that the max length is 23, and this is what we get. The attacker's announcement in this case, even if this entity plays the same trick we've seen before, this would become invalid because, of course, the max length covered is up to /23, and the /24 is outside of that range. So there was a question on Monday about what is the best practice for creating ROAs. My personal suggestion is to create ROAs that cover specifically your BGP announcements. Just be strict. Same as you do with route objects. The issue here might be that if you create such a strict environment, if you want to change something, it will take time. We're all used to changing root objects, and when you create a new root object in the RIPE database or any other database, you can assume that with a delay of 20-30 seconds, they will be available for everyone to see them. They will be there, published. And when you query the database, they will show up. With RPKI, this is not exactly the case. Because in RPKI, when you create a new ROA, let's say you're in a situation like this, and you want to allow a /24 to be announced because you're being attacked with a DDoS, and you want your scrubbing center to announce your /24 where the IP is, or the IP or the IP address, or addresses that are being attacked are, then you want to do it quickly. But with RPKI, you cannot assume things will show up immediately. When you create a ROA, get back to that, you have the ROA gets put in a queue because everything needs to be signed. Signatures are an expensive thing to run, because they have to be either delegated to an HSM, to a hardware security module, or they require certain computational capacity. So RIRs tend to batch them and to queue them and then run them in a batch. So it might be, and then there's the time for them to go from the repository to the validator to the router. So there's a chain that needs to be fulfilled in this case as well. So it might take up to an hour. I think we discussed it on Monday with a colleague, Amrish, who's not here. We had a group of researchers together with us, with ISOC, who did a research on the time it takes for ROAs to show up or being deleted. And the time can be up to an hour. So consider this when you're making your choices about creating the correct ROAs for your entries. My suggestion would be to try to find the right balance between covering all your cases and also being safe enough so that you don't follow into the trap of this case, the one that I was showing here with malicious attackers being able to announce your address space and RPKI not catching it. So we have this ROA, and we've seen the content of a ROA. So now with the private key of the LAR gets signed, and then the signature gets propagated to gets propagated. There's the signature that comes from the CA, from the local CA, from the LAR, and then this is also covered by the signature from the root, from the RIR. And this creates a full chain of trust that we can follow every time we want to check if the data in a ROA can be trusted. So in this case, when we want to verify that the ROA is okay, we just go through all the signatures, and if all of them are okay, good. If nothing has been revoked, everything's fine, then we can trust the data in the ROA. So I mentioned it already earlier, that the hierarchy of the certificate follows the allocation hierarchy. So differently from the IRRs, RPKI, and this is an important distinction, RPKI follows the allocation, follows the regional registries. So, for example, in RIPE, you have members, and then every members have the ROAs. This is how you transpose the chain of trust that I was showing you a moment ago into this. You have ROAs, you have members, you have RIPE. Step back. I'm not sure any one of you, well, some of you might be from APNIC, from the APNIC region. In APNIC, and also in LACNIC, there might be an additional step in between. So in APNIC, you have countries such as Japan, China, and India, where you have national internet registries. In that case, there's an additional hop in between, but everything is done according to that same exact hierarchy. In LACNIC, it is true for Mexico and Brazil, where they have national internet registries. And so in Brazil, nic.br is the one that runs the whole show. And they are one of the biggest users of a software I'll talk to you about in a minute that's called Krill. So the system can be used in two ways. You have right on the top, and you as a member can either go for a hosted version of RPKI or for a delegated version of RPKI. When it's hosted, it means that, in this case, RIPE-NCC does everything for you. And you'll see when in a moment when I show you the demo that actually the creation and deletion, every action regarding ROAS is very, very simple. You just go on a portal, you say, the portal shows you your BGP announcements, and then you can create ROAS according to the specific BGP announcements, or you can create ROAS manually, however you want. This is enough if you have a small network. This is perfect even if you have a large network where things don't change too much. I operate a very, very small network, of course. And but if you are a network that has different allocations in different regions, if you change things very often, then you might want to go for what's called delegated RPKI, which is a situation where you run delegated RPKI, you run your own certificate authority software. There are two implementations available nowadays. One is from Dragon Research Labs called the RPKI Toolkit or RPKI.net, and Krill from NLNet Labs. If you were to start now, I would suggest you look at Krill, because RPKI.net or the RPKI Toolkit is a bit outdated at the moment. It even doesn't run on Python 3. It runs on Python 2. What's tricky about running delegated RPKI? It's not that complicated, but the tricky part is that, of course, you have an additional software to take care of. You have an additional system to monitor. You have additional actions. And then you have also to make a choice. Because you create your ROAS, you create your information, but then you have to publish it. And publishing it means publishing rsync, an rsync server, and at the same time, an HTTPS server. Because data in RPKI gets distributed using two methods, either RPKI or RRDP. And RRDP is just a system that's based on HTTPS, on a web server, basically. So you will you will need to run both. Or there's another choice. You can publish at the parent. So you create your ROAS, you get everything signed by the parent, you have your signed objects, and then you upload them to, say, the RIPE-NCC, so that the RIPE-NCC puts them into their repository. And then people don't have to contact your local repository to get your ROAS, to get your certificates, but they can just get them from the RIPE-NCC. And that's a quicker way of doing that. There's a discussion going on these days. Well, not really a discussion, but there's a change happening where, let's assume you are a network that has resources, so networks, prefixes, allocated from ARIN, RIPE, and APNIC. How would you go about this? You could run your delegated RPKI, you could run your own Krill, and then the RFCs don't mention anything about where you should be publishing your objects. So recently, so I think Friday, ARIN announced that they are publishing service. So ARIN has one. RIPE doesn't have one yet, but they're almost going to announce about it. So ARIN announced on Friday that you can use their repository to upload all objects from any other RIR. So you could just do one transfer at that point, and you should be fine. So the idea is that you have different publishing points. You have the chance to take your favorite regional registry and use them as your publication point. So delegated RPKI, to sum it up, is not that complicated. It just requires you to run additional software, maybe set up an additional VM or an additional physical server. It gives you the same exact functionalities you get from hosted RPKI, which is very, very simple instead. But depending on your needs, you might want to go for delegated. And then at RIPE, you can also certify PI resources. There's a specific procedure. There's a wizard you want to follow so that your PI resources can also be certified by their end users. So I'm going to do now a demo about creating ROAs, creating and managing ROAs. So let me unshare my screen and let me share the other one. No, this is the one I want. 1 second, and here we go. So this is the LIR portal. This is the point where you talk always to the RIPE NCC. I'm going to log in. Couldn't do it earlier because otherwise it would have timed out by the time I got in here. So username and password. And you could see that it's a reused password. I think it's only, I'm not sure where I've reused that, but this is the LIR portal. I can go into the RPKI dashboard, which is a dedicated area where I just deal with RPKI. And as you can see, I have my own ASN, AS58280. I have a /29. Current status is valid for IPv6, and current status is valid for IPv4 as well. So these are two of the networks I have. But then if I look at the ROAs, I have more. You see, I have a ROA here that also has a different origin. Let's do one thing. Let's delete this one. When I touch something, I add or delete, it always gets staged. So now we'll have to click here and say review. I see that there's a ROA that would be deleted. And I can say apply the change. Only when I apply the change, the ROA gets actually deleted. So now you can see I have 3 ROAs, one for a /29 IPv6. This is also an allocation I have for testing. This is the /29 IPv6 from which I'm talking to you, the one that serves my network. Another /22 that also serves my network. So what I can do is I can say, let's create a new ROA. We have an AS number that's 141384. This is the AS number for a small lab we have at ISOC. The prefixes should be one of my prefixes. So this is a /24 I have in my allocations, but let's try one thing. This is the last network. So if I try to do 228.0/24, what's going to happen? You see, the prefix must belong to my certified resources. So there is a check that happens whenever I type a network there. The RIPE NCC knows exactly which resources I'm holding, so they can do a quick check to say, is this network yours, or are you trying to set up a ROA for someone else? So this is a very, very important feature for RPKI in this case. So let's create this. max length, let's be generous. Let's do up to /28. And let's save it. So it gets staged and it tells me this is new. Can review and say, do I, this looks good, apply the change. Voila, and the row is created. Now, it is created in the dashboard. I'm not sure 100% it is created right now, but we can assume that in the next 5-10 minutes, it will be created. So we will get to a point where we can see that in the ROAS. We can see that in our validators when we start seeing them. So this was a very, very quick demo. But it's about RIPE-NCC, but Afrinic, ARIN, LACNIC, and APNIC all have a very, very similar environment where things are very easy to set up. Do we have any question before I go on, before we turn into talking about validators? I know it's morning for everyone. So let me start sharing the slides again. And this way I can give you more time to think about any questions you might have. Me and my chat again. There we go. So I can keep an eye. Perfect. So RPKI validators. We're now looking at the other side of RPKI. We're looking at the validation. We're looking at picking the data, taking the data that other people have provided with the signatures and verifying the truthfulness of BGP announcements in this case. And we have two building blocks. One is the validators and one then is the validating action. So validators are a special kind of software that creates what is called a validated cache with all the valid ROAs, which then are called VRPs, verified router payloads. So the way they do it is they download the way the validators do it is they download the RPKI repositories from the RIRs and from the private repositories, private publication points from all the people who run the delegated RPKI, validates the chain of trust of everything, and then talks to the routers using a dedicated protocol called RPKI RTR, which is very, very simple. So in a graphic, how does this work? You have the different regional registries. They all have the repositories. Actually, not all of them. Get to that in a moment. And they have a file they distribute called the TAL, the Trust Anchor Locator. That file contains the location of the repositories, so the URLs for rsync and RRDP, and then the public key for that registry. You see that ARIN doesn't have a green check above them, and there is no TAL next to their arrow. That's because ARIN used to not distribute their TAL. You had to manually go and download it from their website to acknowledge, and then you had to acknowledge specific terms and conditions. Things have changed. There's an agreement now with the developers of the different validators. And so the ARIN TAL is actually distributed. But before you can use it, you still have to type yes to agree with the terms and conditions proposed. So it's just a legal addition to running RPKI. But then you get to use the full ARIN TAL. Now, the way it works is that all the data gets to the validator, and the validator provides it to the router. And the router, imagine you're a router, you get ROAS on one side, you get BGP announcements on the other. And then with this, you can make what are called better routing decisions, which means you have an additional data point, the ROA, with additional, more detailed data points inside that can tell the router, yes, this BGP announcement is good. No, this BGP announcement is bad. Or we don't have any data because there's no ROA covering that address space. We don't have any data to verify how that prefix looks like. So the router gets additional data to make better routing decisions this way. There are 4 main implementations for validators. Routinator is the one that I personally like the most, built by NLNet Labs using Rust. There is RPKI client from OpenBSD. It's part of the OpenBSD project, but it also has portable versions. So you can also install it on Ubuntu and I think FreeBSD. Then there is Octo RPKI, which comes from Cloudflare, and then Fort. Fort, written by the Nick in Mexico, and written in C, very strong implementation as well. Now, the 3 that I would recommend are Routinator, RPKI client, and Fort. I personally run Routinator and Fort. Octo RPKI has a small issue where the person who was maintaining it at Cloudflare left, and so far it doesn't seem anyone else picked it up as a project inside the organization. So it might be that it gets to become obsolete pretty soon, unfortunately. But the suggestion is to always run 2 validators at least on different hosts for every POP. So here's the suggestion. Run at least 2. The suggestion here is Routinator and Fort as a couple. Configure the correct tiles. In this case, they have already been downloaded. Normally, the software now distributes them, and the RN tile needs to be acknowledged separately. So how does this work? This is an example where in running Routinator and Fort. Installing them, very, very simple. They come in packages from Ubuntu or every distribution, every Linux distribution, they come as a port on FreeBSD, they come as ports on OpenBSD, so they're available everywhere. So the installation changes depending on your package manager, whatever, but running Routinator is very simple. You run Routinator server, run my RTR daemon and bind it to this IP address on this port, but then it will come up with an error. It tells, hey, there's the missing tile directory. In this case, this is an example, the first square up here. You may have to initialize it via a Routinator init. And you run the Routinator init, and it tells you, well, before we can install the RN tile, you must have read and agree to the RN relying party agreement. It's available at blah, blah, blah. There's a URL that's hidden in there, sorry. And then if you agree to the RPA, please run the command again with the accept RN RPA option. And then it installs also the RN tile. And at which point you can run, again, Routinator server, and then just check if it's running. And PS should be telling you that there's an instance of Routinator running at that point. Do you have any question on Routinator? No questions? Okay. And if there are no questions, I'll go ahead with Fort. Fort has a very, very similar behavior. You try to start Fort from system control, check if it's running, and it will give you an error because, well, you have to init the tiles. And then you run the same, very similar command to the one you ran with Routinator. And then you have to explicitly accept the RPA, the relying party agreement from Aaron. When you say yes, all the tiles get installed. So you can then fetch all the ROAs from all the sources. So far, so good. Now, I have already run these the validators from on their own dedicated hosts. So we'll use them later in the origin validation example. But it seems you have no questions so far. So let me ask a question. Has any one of you ever installed already a validator? I mean, I see Flavio Luciani, who used to be also, who was an ambassador for Manners last year, and I know he has installed an enormous amount of validators. But what about the others? No, Paul, okay. Manny from Tiago, okay. Okay, so installing a validator is very simple. There's the package, and then running it is very simple, as you could see. Then they don't require a large amount of resources. All the VMs that we have for so part of my job is also helping internet exchanges, and we have a bunch of internet exchanges we've been working with, and with all of them we encourage them to run instances of the validators. And a VM with 2 gigs of RAM and 1 core, maybe it's better to have 2 cores, can really handle the validators. Now, good question. Okay, do I know if RIPE plans to use Krill like Nick BR? I don't think they plan on that. I think they do have some parts. I think they have some parts that use some features out of Krill, but the RIPE NCC has their own platform that they created with their own HSMs to create, delete ROAs, to manage all the RPKI repository. I know they work together very closely with NLNet Labs, but I'm not sure about how much of Krill will come into the RIPE NCC infrastructure. I used to work at RIPE NCC, but it was up to 3 years ago. So things might have changed in the meantime. You're welcome. Okay. We don't seem to have any other questions, so I will go ahead with the validation. Validation runs with a validator, as we've seen, gets the ROAs, the certificates, so the whole RPKI repository. Gets it by using rsync or RRDP. And then the validator creates a validated cache. So there is an action that happens between the download of all the data and the creation of the validated cache. The validated cache only contains ROAs that have passed the check of the chain of trust. So ROAs who are from an LIR or a member that didn't pay their fees and had their certificate authority or certificates revoked, they don't make it into the validated cache. And then after that, the validated cache provides data to run BGP origin validation. So we have 2 stages, and this is important to understand. One stage up here where we verify the validity of the ROAs. So we verify the validity of the certificates, we verify the chain of trust. So we do what I would call a policy check. And then we go into a technical check. We have all the ROAs that made it here. The router can use them to say if an announcement is good or it's bad. So the validation works following the chain of trust. And then by getting ROAs, this is an example. We have a AS100 announcing or supposedly announcing 10.0/22. This is transferred via RPKI RTR to the router. And then when the router receives an announcement, let's say from AS100, in this case, it's the /22 announced by AS100. This fits all completely. This matches what we have in the ROA. So the announcement is good. But if AS100 tries to announce a /24 out of the same address range, there is nothing that matches here. So the announcement should be considered invalid. There is one little piece of information we're missing here in the ROA, that's the max length. But when there isn't, when it is not specified, max length is the same as the prefix length. So that's when you're strict. Same thing we verify when we get an announcement from AS200. See, we have 10.0/22 being announced by AS200, but AS200 is not listed as an origin for our from our ROA. So this announcement should be considered invalid and should be discarded. So this is important to understand. So let me ask you again, is this all clear? Is this all good? Because if I don't get questions, it either means that you're too confused to ask one or you've fully understood, which I hope is the case here. I know, but I always say that. I mean, I used to give training courses all the time, and not seeing faces of people doesn't give me any hints if you're understanding it or not. But that's good. It's good to read that at least 3 people say that everything's understood or clear. That's good. So let's go ahead. What are the states for validation? We've said that there are, I mentioned it already, there are two separate parts we have to consider, 2 separate validations. One is about the ROAs and one is about BGP. So if we look at at ROAs, ROAs can be valid. As I said, they fulfill the chain of trust. They're good. Everything's fine. They're considered valid. If they don't, if there's anything wrong with their certificate, with their signatures, anything, they become invalid and they stop here. So they are not shown in the validated cache. But when they're considered valid, they become part of the BGP origin validation process. And as we've seen in the previous slide, if they match completely with the origin, with the prefix length, and they fall into and the BGP announcement falls into the max length, then the BGP announcement is then considered valid. If there's anything wrong, such as the ASN not matching the one that's listed as origin, or a different prefix length from the max length, then the BGP announcement is considered invalid. The case where we have not found is when we don't have a ROA to verify the BGP announcement. Because in this case, our router cannot make any decision, cannot tell if something is valid or invalid, because they don't have any data point to use. So the origin validation process will give us a not found status. And we'll see these when we do the demo later on. But before we can get to the demo, we have local changes to the ROA database. Imagine you're in a situation where you have AS100 announcing a /24. They created ROAs that are wrong, but you know that that announcement is legitimate, and your customers are complaining that they can't reach AS100 because you are discarding that BGP announcement because it's invalid, of course. What can you do? Every validator has a feature that uses a system called Slurm, where you can tell the validator, hey, I'm creating an allow list. Still, it's actually called the whitelist. I put it here as allow list, where you create an artificial ROA that's only used inside your own validator. It does not get propagated to anyone else, where you say, this is an artificial ROA. I want you to create, dear validator, inside your validated cache for this BGP, for these resources. So in this case, we add this, and immediately this BGP announcement, this /24, becomes valid. Now, I have a very, very big suggestion for you if you ever do something like this. I know if you run a network, you might have customers complaining. That's fine. You have to do what's better for your customers, for you and your customers. But one suggestion is if you create something in Slurm, with Slurm, in your validator, put something in your calendar in a few days, time, to check back that the announcement is still invalid if you remove that that entry from your validator. You don't want to leave assertions. You don't want to leave this data lying in your validator for long. Make sure. Yes. Okay. I see a question from Paul. The question is, why not just create a ROA with the right max length instead of using Slurm? Because that is not your resource. It's someone else's resource. You're not allowed to create ROAs for that. So the resource would be from AS100, not from you. Let's assume here you're AS200. It's someone else's resource you're creating the fake ROA for, because that is affecting you. You might understand if you look at BGP, if you look at everything, you would understand that that is a legitimate BGP announcement. It's considered invalid because someone didn't consider the effect of creating maybe that new BGP announcement. Maybe that's a dedicated /24. The other ISP or the other data center is announcing via a different upstream, or they wanted to do traffic engineering. So they're announcing that /24 separately, but no one has considered the fact that there is a covering ROA that doesn't allow that /24 to be announced. Give me 1 second to close the window, because I've heard too much from the window. Give me 1 second. Sorry about that. It's the effect of having a garden outside your window, and it's nice weather outside. So getting back to this, you're affecting someone else's ROAs in this case. That's why you create it in Slurm. You would not be allowed to do it in the RIPE database, sorry, in the RIPE certification page or anywhere else. So that is the trick. And I see that now is clear for a bunch of people, so we can go ahead. So here's an example of how you do origin validation. It's not that complicated. The first thing you need to do, this is an example with Cisco. And we have two examples, one with Cisco, one with Juniper. The one with Cisco is the way you should be doing it. The one with Juniper, less so, but I'll explain why. So here the first thing we need to do is to tell the router where the validators are, because the router needs to fetch all the ROAs from them, from their validated cache. So in this case, we have two validators running on two different ports on the same host. This comes from a lab that we had set up also when I was at RIPE NCC, but it's an example that would perfectly work. It was working in our lab. Then what you do is create a route map. You create a route map where you first of all match the valid, set a local preference of 100, and then you set another rule to match the not found, and then set a local preference to 80. Now, this is all we're doing here. What we do here is we get to accept both the valid and not found. We are not creating any specific entry for not found, sorry, for invalid, because we just say discarded. The final situation is that all the matches with RPKI invalid, they will be discarded, and that's what we want to do in the end. And here we do just a trick to set different local preference to valid and not found. That's not going to have most likely any effect on our final routing, but it would just be a way also for us to understand which one is which. Now, I've created the route map. And what I need to do is just apply that route map incoming in the in queue to my neighbors, and that's it. And once I do this, I just have to clear my BGP sessions. Well, or if I have software configuration inbound, just apply that, reconfigure the session, and then my invalids will be discarded. With Juniper, the configuration is similar. Of course, the syntax is a bit different, but I set up my validators, ports and local address, remote address. This is an example. And then I create a policy statement where I check the term valid, validation database valid, and then I say accept it, set the local preference to 110, and then I can add a specific community that's defined in as a default also in Juniper to say this prefix has a status valid. I can do it for invalid as well. And that's why I said you should not be doing that, because in this case, we're just lowering the local preference, but accepting it anyways. It's not good to do. We shouldn't be doing this slide, but this is also an example you can follow if you maybe want to apply something, some other rules or something else. And then we have validation state unknown, which is the same as not found. And what we do is accept, keep the local preference the same, as, so we don't affect the local preference, but we say add the community that says the origin validation state is unknown. So far, so good. I see someone had to leave. That's unfortunate. But here we are. I have a demo for route origin validation. So if there are no questions, I will go with it. Okay, 1 second. Let me share my screen. Where is my terminal? Here we go. There we go. So I have this router that has all these networks in here. And as you can see, I have next stop. The path says that the origin is 58280. You might be recognizing this is one of the networks a network for which I created I have a ROA, a valid ROA. Forget about the others. This is the one. And there's a /24 that should not be here. But for now, we don't have a way to figure it out. You see, there is an entry here that says RPKI validation codes, V valid, I invalid, and not found, but we don't have that information anywhere. So let me put this here. So let me go back to the slides for a second. And what we have is, sometimes you get lost between all the screens. Keynote. So we have this, well, this would be AS101. We have the validator. We have AS101. That's the one we're working with. Then we have announcement from AS58280, which is our transit. This is invalid. This one, this /24, is supposedly invalid. But for now, we don't have data to verify that. We're going to use RPKI to find that. So going back to my terminal. Okay, first thing we need to do is T. This is not Cisco. This looks like Cisco, but it's called FRR, free range routing. It has a very similar CLI to Cisco, but something is slightly different. So in this case, you'll see that differently from the previous example on the slides. We go into RPKI, so config RPKI, and then I have to say RPKI cache. And then I have an IP address for the caches we run here at ISOC. 143.28, port 3323. And here I set a preference. So I tell my router, this is my preferred cache. So try this one first, and then try this one second. 162.143.29, port 8323, preference 2. I set these two. So I go say end, and then I can show RPKI prefix table. And when I check this, you see I get a table that has prefix, net mask, max length, origin. So these are my ROAs in here. These are all my ROAs, and I have 285,000 for IPv4, 68,000 for IPv6. They're called prefixes because the trick they used is they give you, basically it's another routing table that's being used. Now, see, one thing that I really always highlight when I run this command is look at this. They created a ROA for a /32, which allows up to a /127. This opens so many possibilities of creating issues. Also this one, 32 up to /64. Even this one, up to 48. So there are many examples here of what you kind of should not do, as you can see. Anyway, we're here. Next step is to create the route map. We call it route map RPKI in, let's say permit, let's say 20. Then we do a match RPKI not found for the moment. And then we say set local preference to 100. Let's leave it like that. So we match not found. Then we do the next one, route map RPKI in permit 30, and we say match RPKI valid. And then what we can do here is that set local preference to say 120. So we erase the local preference for whatever is valid. So here we're finished with this, finished with the route map. And then the next part is to go into our definition. So let me do a show run. You see that we have a BGP session. Our neighbor is 10.1.0.2, and we have the address family here. So we need to go router 101, BGP 101. Hold on. Before we do this, show IP BGP. Now, you see that we have an additional information here, and now we have it next to the prefixes. So here it's telling us that this is a valid prefix, the /22. This is invalid. Oops. This is invalid. This one is valid, and the others are all invalid because they're all more specifics. So what can we do here? We need to take the route map, apply it to the BGP neighbor, and then with that, show run. So I get the IP address of the neighbor. With that, we should see the networks that shouldn't be there. We should see them going away. Router BGP 101, address family IPv4 unicast. And then we have neighbor, blah, blah, blah. Route map, RPKI in. Now, course, so let's show IPBGP. Voila. You see that we have these, the invalid networks are gone. And we have implemented BGP origin validation in 5 minutes. Of course, I know if you have a more complex network setup, it's going to be a little bit more complex, but this is a quick example of how you can do this very effectively and leaving out all the invalid routes that are in the world. Let me check the chat if there are any questions. I see no questions. Okay, so I'll share my slides again. So let me show you again. This is a summary. I was following this, of course, as a reference. We've set up our RPKI caches. So we told the router, go here to get using RPKI RTR, go get your ROAs, your VRPs. Then we checked if it worked, showed the RPKI prefix table. Then we created the route map with 2 matches, one for the not found, so the unknown ROA state, and then match the ones where the RPKI state is valid. We don't match the invalids, we just drop them. And then we applied the route map to the neighbor. And then with this, the /24 has disappeared along with other networks from our table. So we're filtering invalids. Our network should be safer now. Now, the other actions you could do would be to tag the validated routes with a specific community, like we were doing in the Cisco example, and the not found ones with another community. So you could carry this information internally in your network. It's something that sometimes is not really recommended. There is there are pros and cons to this. You could also have a system to check what you are discarding, so that you make sure you're not discarding invalids that are supposed to be valid, and then you could notify the holders of that address space. Make it so that you get a notification, and then you check if it's a case to create the slurm entries or not. It all depends on how you run your network, what your interests are, and also how your customers or how your the rest of your colleagues feels about adding more and more monitoring. You can run the origin validation check, although on Monday they told me that this is actually broken. So I will also need to go back to RIPE-NCC and tell them that this needs to be fixed. But this is a system where you can go and check if the network where you are does origin validation or not. And it does it in a simple way. Let's see if you can imagine how you can do that. Imagine you have a browser and you want to verify that the network is doing origin validation. How would you do that? Let's see if anyone would like to take this up and see if you can give an explanation. I see no one yet. So you have a browser, you open a website, and then via JavaScript, the system tries to fetch 2 different small images, one from a network that's fully validated and one from a network that is not, that is invalid. And at that point, you have a situation where if you can fetch the image from the invalid network, no origin validation is being applied. If you cannot fetch it, if it times out, then it means your network is protected. and there's no way to reach the invalid network. It's a very simple trick you can do in JavaScript in a bit. So far, so good. We have the very last section with some suggestions. The suggestion is, and I've given it already, run multiple validators, both in type and location. I run a small network, and what I do is, well, I don't run hardware routers, I run software routers, I run BERT on FreeBSD. And what I do is for every POP, I have a router that runs BERT on the direct hardware. And then I have 2 jails, one for routinator, one for Fort. So I have local RTRs for every location. And then I run a resolver and a few other daemons. But the concept here is to run multiple validators, multiple different implementations. So I personally run the same as suggested here in the tutorial, routinator and Fort. But then the important part is also to monitor them. Monitor that you can connect to them and that the serial number keeps increasing. I've had a case where the validators were running perfectly, just they were not updating the data in there for a few days. I don't know what the issue was, but then you want something that checks that the serial number keeps going up or keeps changing. Then BGP Alerter was presented also yesterday. Is a tool written in JavaScript and Node, using Node, to monitor your BGP announcements. So it can alert you if there's anything changing in your BGP announcements, if there's anything changing in your network, if there's anyone trying to hijack you. The setup is very quick. So you download it, you download the pre-built binary, you just run it, it asks you questions, what you want to monitor exactly, and then it starts running. And it monitors changes in the announcements based on data from RIS Live, from the streaming API from RIS. RIS is the routing information system, the route collector network that the RIPE-NCC runs. So you get multiple different points of view about all BGP announcements. So you can be sure that what you see is somewhere in the world. So I would recommend you to run BGP Alerter, even if you don't run RPKI, because it gives you an insight into how things are going for your network. Then we have the manners tutorials. We have training tutorials based on information on the implementation guide. And then we have a hands-on lab that you can do following the tutorials. And then last, you can join Manners. Go to manners.org, look at the different actions you should take and be prepared for before you submit your request to join. And then once you join it, you can join the community, get more involved, follow the example from Flavio, from Massimo, the other ambassadors, or the other, I don't remember how they're called, but anyway, get involved in the community to help us spread more knowledge about manners, about what you should be doing for improving to improve routing security in the world. And this was really my last slide. We would still have half an hour, but this is the half hour that on Monday was taken up by the presentation from IRR Explorer. And so we're perfectly on time, actually. I'm here if you have any questions, but in another case, thank you very much for being here today. I've read good comments in the chat. We weren't that many, but still nice to see 15 people joining the tutorial today, early in the morning or during the day for you. And if you have any questions, here is my email address, my Twitter account, and then you can also contact me on Telegram. Oops, let me send it to everyone in the chat. You can also find me there. And I see you either later today in the next presentation for the day. Today, there's a very interesting session with all the regional registries this afternoon, so check the calendar. Or I see you maybe at other meetings or in other events. So thank you very much.